value. Here we discuss combination of errors. Combination of errors, when it comes, you are getting the errors to combine. So where it comes? Let us see. If I am measuring acceleration due to gravity using a simple pendulum in the lab. Simple pendulum you all might have seen in the lab. A small heavy ball attached to a long string and made to oscillate. Using that simple apparatus, we can determine the acceleration due to gravity, and for that I have the equation G equal to 4 pi square L by T square. For example, this is the equation for finding the acceleration due to gravity. Now, the L is the length of the simple pendulum and capital T is the time period of oscillation of the simple pendulum. So, you are measuring two quantities. One is length of the pendulum. So, there can be an error in that length measurement, or you will be getting the length measured as L plus or minus delta L. And when you measure this time period of oscillation, counting 20 oscillations along with a stopwatch starter, there can be error possible in the measurement of counting and all that things, and finally when you calculate the time period, you will be getting capital T plus or minus delta T. That is time period with an error in it. So when you measure the quantities with errors, these two quantities, and substitute into this particular equation, you won't be getting the exact acceleration due to gravity. You will be getting a value which is G plus or minus delta G. So this plus or minus delta G, that is the error in the final measurement, will be depending on the error in the measurement of length and also error in the measurement of time period. So when you take those two errors and substitute in this equation, and how those two errors are getting propagated through your calculations to appear into the final result. This is what is meant by combination of errors. So here we are getting a multiplication process here and a division like that. So to get the idea of this one, this just to introduce what is meant by combination of errors. Now we are going to see, depending upon each and every simple mathematical procedures, addition, subtraction, multiplication, division, etc., how the error can be getting added up or propagating through the mathematical procedure. Okay? So, let us take the first case, that is addition process. Now suppose I have a quantity, a physical quantity, that is set, which is given by the sum of two other physical quantities, A, whatever it is. So I have to measure A and measure B, and adding those two measurements I will be getting set. So when I measure A, I will be getting A plus or minus delta A with error, and when I measure B, I will be getting B plus or minus delta B with error. So I will be substituting these two into this equation. That means I will be adding A plus or minus delta A plus B plus or minus delta B. So it's sure that I won't be getting set, I will be getting instead set plus or minus delta set only. So set plus or minus delta set therefore will be equal to, being a simple addition process, I can remove the bracket directly. There is no difference at all. Okay. And I can rewrite this as a plus b, taking these two together, plus or minus delta a plus or minus delta b. Now we know that a plus b, this a plus b is nothing but equal to z. So from this one, I am left with plus or minus delta z will be equal to plus or minus delta a plus or minus delta b. So I will be having 4 chances here. That are plus delta a plus delta b, plus delta a minus delta b, minus delta a plus delta b, and minus delta a minus delta b. 4 different chances possible. But at this stage, we'll be considering a statement that is maximum possible error. Maximum possible error in the final measurement. Maximum possible error in the final measurement therefore will be equal to delta z. That is the maximum possible error will be equal to delta a plus delta b. So this result is what you are supposed to remember in the addition process. So when the two quantities are getting added to get a third physical quantity, there are the individual measurements are getting added to appear in the final measurement. Okay? Now, if you do the subtraction process, this is the addition process we started with. Now, if you continue with subtraction process, subtraction when it comes a minus b, you will be following the same step. And you can find that in that case also, maximum possible error in the final measurement will be again the same. So remember, the maximum possible error in the final measurement of addition process and subtraction process is nothing but the sum of the errors in the individual measurements. Okay? This is what about the addition process and subtraction process. And you have to remember only the final result for the two. Now, to understand where we are applying this one, I will give you a small example. Small example I am telling you. That is, I measured the length of the room as 10 plus or minus 0.03 meter. Okay. Now, length of the next room is 9 plus or minus 0.01 meter. So if you are asking you to find the total length of the two rooms, you are supposed to add the two and get the final. So when I add the two results, I will be adding the actual value first, like these two are the actual values. So 10 plus 9, 19 meter. This is the actual value of the total length of the room. Now come to the next one, plus or minus. Now you apply this condition. Maximum possible error is delta A plus delta B, delta A1 plus delta A2, that is 0.05. meter. This is what we do for finding the total length of the room. Just for applying the result, how it is. Now instead, if I am asking to find what is the difference in length of the room, if we are asked to find the difference in length of the room with the maximum possible error, then you will be taking a meter, then 9 plus or minus 0.01 meter. What is the difference between the two lengths? You will be taking the difference. First one minus the other one. So when you do that here, first actual values, 10 minus 9, 1 meter. Then go for the other part. For subtraction also, maximum possible error will be equal to sum of the individual errors. Yes, 0.04 meter. So maximum possible error in subtraction, maximum possible error in addition, you can see they are the same because of the result we found. Okay, keep in mind the actual value will be added first or subtracted, then go for the error part. This is the method for addition and subtraction. Okay, practice this type of questions from the text.